This next section is one of my favorites of pre-calculus algebra. I really can't explain why. I just like doing these. It's kind of weird, but yeah. Anyway, so we've got several different rules that we're going to learn today. The first one is called the product rule. What it says is, if the log base b of m times n, if you're given log base b of m times n, that is the same thing as the log base b of m plus the log base b of n. So if you're multiplying in here, then you're adding when you can separate them or expand. So if we use the product rule to rewrite this logarithm, then we're multiplying. So we're going to add log base 6 of 7 plus log base 6 of 11. And it's that simple. For this one, same type deal. This is addition, so we're not going to mess with that. We're just going to deal with the multiplication here. So we would say log base 6 of x plus log base 6 of x plus 1. And notice I did put that x plus 1 in parentheses there because it's of all the x plus 1. If I didn't, don't erase that. If I wrote it like this, then it would look like log base 6 of x and then plus 1. So we've got to make sure we keep it in parentheses. The quotient rule says that if there's division, then you subtract. So log base b of m divided by n is the same thing as log base b of m minus log base b of n. So using the quotient rule here, we would say log base 8 of 23 minus log base 8 of x. The next rule is called the power rule. If you have log base b of m to the p power, you can bring that p out front, which is a very nice thing. That is then equal to p times log base b of m. So the example here, log base 6 of 3 to the 9th power, we can bring the 9 out front and say 9 times log base 6 of 3. And when we start solving equations, especially in the next section, you'll see why this is useful more. For b, we need to rewrite this first. We've got log of the third root of x squared. We need to rewrite that as just an exponent. So the third root of x squared is the same thing as x to the 2/3, remembering your exponent rules. So you can bring the 2/3 out front and say 2/3 times log of x. So the next couple of examples, we're going to use all these rules together. So we've got log base b of x to the 4th times the third root of y. So that multiplication here can be rewritten as addition. So we'll start with that. Log base b of x to the 4th plus log base b of the third root of y. Now, we can bring this 4 out front, but before I do that, I'm just going to bring this down, and we're going to go ahead and rewrite that third root of y as y to the 1/3. And now, the 4 can come out front here to rewrite as 4 times log base b of x And the 1/3 comes out in front of that log, so we'll write plus 1/3 times log base b of y. For example 5, it says use the logarithmic properties to expand the expression log base 5 of the square root of x over 25y cubed. So we want to start using order of operations. We would deal with the division first here. So we want to start with division. And with division, we're going to separate into subtraction. So log base 5 of square root of x, I'm going to go ahead and change that to x to the 1/2. Then minus log base 5 of 25y cubed. Okay, I'll change that the next step. Okay, so now I'm going to go ahead and change that x, square root of x, to x to the 1/2. And then we have log base 5 of 25 times y cubed. And with multiplication, we change to addition. Now, since we've got this minus here, then we've got to put this next part in parentheses for now. Log base 5 of 25 plus log base 5 of y cubed. Then we can distribute. Distribute the negative, so we'll have minus log base 5. 25 is 5 squared. And when we distribute the negative, minus log base 5 of y cubed. Now let's go back to this 25. Whenever you're working through these, you want to look at the of spot, which is where the 25 is. And if that's something that you can change into a number with an exponent, then you need to do that so that you can bring your exponent out front later. So now we can bring all these exponents out to the front. So we'll have 1/2 log base 5 of x minus 2 log base 5 of 5 minus 3 log base 5 of y. Now there's one more thing we can do here. Realize that log base 5 of 5, that's one of our properties that we know, would give us 1. Log base 5 of 5 is 1. So that means that 2 times 1 here is just 2. So we get rid of the log there altogether. And I would rewrite this to have the 2 at the end, but it's not wrong if you don't. Just because it looks better to have the constant at the end. But so there we go. Now we're going to work backwards. So we've got addition going on. We can change that back to multiplication. It says write as a single logarithm. So that would be log of 25 times 4. Well, 25 times 4 is 100. So here we are written as a single logarithm. But the fact is, we could simplify this even more. That's the same thing as log base 10 of 10 squared, which is 2. And this one's quite long. Let's take a look at it. So first we'll start with, I'm going to start by distributing that 2. So we're just going to say 2 natural log of x minus 2 natural log of x squared, and then plus our 2/3 natural log of z to the 9th minus natural log of z. The next step is to start putting those exponents on. So whatever's out front is going to go on the exponent. So we'll have natural log of x squared minus natural log of x. And instead of x squared, it's x squared squared, or x to the 4th. Let's write that out first. So x squared squared. And then natural log of z to the 9th, also to our 2/3. And then just minus natural log of z. So we can go through and simplify here a little bit. That'll be natural log of x to the 4th plus the natural log of z to the 6th. Now we start combining. Because we've got subtraction here, then we'll say natural log of x squared divided by x to the 4th. Did I leave myself room? Nope. Let me move this over because I'm going to have to. Okay. And then same thing with the addition here. We're going to make that multiplication. So natural log of x squared over x to the 4th times z to the 6th. And now we'll deal with the subtraction. Natural log of x squared times z to the 6th over x to the 4th divided by z. So that means the z goes on the bottom. And now we'll simplify. So since we've got an x squared on top and an x to the 4th on bottom, all the x's go away on the top, and we're left with 2 on the bottom. And all the z's go away on the bottom, and we're left with z to the 5th on the top. So all this reduced down to this little bit here. Here it says, use the fact that log base b of 2 is 0.4307, log base b of 3 is 0.6826, and log base b of 7 is 1.2091 to approximate the value of log base b of 21. Well, we know that log base b of 21 would be the same thing as log base b of 3 times 7. Plus 3 times 7 is 21. Which would be the same thing as log base b of 3 plus log base b of 7. And we've got those numbers up there. Log base b of 3 is 0.6826. And log base b of 7 is 1.2091. Add those in your calculator, you get 1.8917. And part B, we've got log base b of 7 divided by 2. Well, that would be log base b of 7 minus log base b of 2. Log base b of 7 is 1.2091. And log base b of 2 is 0.4307. Put that in your calculator, you get 0.7784. And then our last property is a very useful one. The log base b of m is equal to the log of m over the log of b. And it says base A, not a big deal. We just use log base 10, which is just log, or you can use natural log, which is log base e. So if you've got log base b of m, you can say that that is the log of m over the log of b. Or if you've got log base b of m, you could also say that that's the natural log of m over the natural log of b. As long as you make sure you put the of on the top and the base on the bottom. Oh, I already had that written there. So use common logs, that's log base 10, to evaluate log base 7 of 2,506. That would be the same thing as log of 2,506 over log of 7, which is approximately 4.022. And then we're asked to use natural logs to evaluate the same thing. That would be the natural log of 2,506 over the natural log of 7, also approximately 4.022. And that concludes this section.